Earlier, we discussed designing the research project, which includes identifying the methods, identifying the techniques, and the instruments. And aside from those aspects of the research design, we also have to design the sampling process. In the sampling design, we have to identify how the respondents of the study will be selected. And again, before we start discussing those different ways to choose your sample, we have some important terms about sampling that you have to be familiar with in order to come up with good sampling methodologies. So again, you have the term representative, which refers to a description of a sample if it's a good representation of the population. And a sample is said to be representative if the characteristics of the population are present and observable in the sample. So for example, if your population has a wide set of possible responses for monthly household income, then that should also be present in your sample. Or in terms of gender, if half of the population are females, then the sample should also be composed of half females. So again, a data set or a sample is considered representative if the characteristics of the population are also existing or observable in the sample. Now, another important term is the target population, and this is usually synonymous to the population of the study. So this refers to the set of all elements that we wish to study for a particular research. Now, another term is the sampling frame. And in most cases, the sampling frame is different from the target population or just the population. The sampling frame is just a listing or a data set of all the possible respondents for the survey. So if you have a target population, ideally the sampling frame should contain all possible elements in that population. But in a lot of cases, the sampling frame has a smaller scope as compared to the target population. For example, if your target population refers to everyone in the Philippines, in most cases, we don't have a data set which includes every member of that population. We don't have a data set providing us everyone in the Philippines. So what we can use instead is maybe the list of all those who are eligible voters. So that's something that we can obtain from the Commission on Elections. Or another possible sampling frame is the list of recipients of the conditional cash transfer program of the government. So again, that is your sampling frame. It's a list of possible respondents for your survey. And in those situations that I mentioned earlier, the sampling frame is different from the target population. So the goal for any study is to come up with a sampling frame that is almost the same or almost similar to the target population. In some cases, it's impossible to do, it's very difficult to do. So just try to research for different possible sources of the elements so that we can be able to get a better representative of the population. And then you have the term observation unit or element, and this refers to the individual members of the population where we get the data from. So if your population again refers to people in the Philippines, then an element is one person living in the Philippines. Or if your study is about cars produced by Toyota in 2016, then the observation unit or an element is just one of all those cars produced in 2016. So those are very important terms about sampling. Now for sampling designs, there are two major categories. We have probability sampling and non-probability sampling. And the main difference between the two is that for probability sampling, there is randomness involved in the selection of the respondents in the study. Now, the implication here is that if the study involve the use of probability sampling, then it's possible for us to make a generalization for the entire population because probability sampling allows us to have a representative sample. So it allows us to use inferential statistics tool so that even if the data just comes from a sample, it will be enough for us to describe the entire population. And consequently, if the sampling design utilized a non-probability sampling method, then most probably the data set that will be obtained from that method is biased, which makes it not valid or inappropriate for us to use inferential statistics. So if your goal is to generalize for the bigger population, then you have to use a probability sampling method. Now, there are four commonly used probability sampling methods. The first is the simple random sampling. Here, every member in the population has an equal chance of being in the sample. You can think of it as having a bowl with multiple numbers inside of it, and simple random sampling just involves randomly selecting items from the bowl until you get the target number of respondents. So here again, every member has an equal chance regardless of the number of elements in the population. And that's usually possible if you can identify all the elements in your population. So if you have a bowl and all the elements in the population are present in the bowl, then it's possible for you to just randomly select among all those elements, making the probability for each element similar. Now, another probability sampling method is systematic probability sampling. Here, only the first element will be randomly selected and the succeeding ones will be selected more systematically. And for us to do that, we have to compute first for an interval, which is represented by k, and this is computed by dividing the total number of elements in the population, that's capital N, and we divide that by the target number of respondents, which is small letter n. So for example, if your population has 1,000 units or 1,000 elements, and your target number of respondents in your sample is 100, then your k will be equal to 10. So to perform systematic sampling, we will randomly select the first element from the first 10 because that's the value of your k. So since your k is 10, we will randomly select the first from 1 to 10. So let's say you have a database. The database has all those 1,000 possible respondents. You will only select among the first 10. So randomly select 1 out of the first 10. Let's say out of the 10 first numbers, we randomly got 7. So 7 will be your first respondent, and then the succeeding respondents will be selected using the same interval of 10. So if the first respondent is 7, then the next respondent will be 7 plus k, or 10, which is 17. So the 17th number in the dataset will be your second respondent. And the third respondent will be 27, followed by 37, and so on. So doing that, until you reach your target of 100, you will just keep on adding the same interval for you to choose all your respondents. So we call that systematic probability sampling. Another probability sampling method is called stratified sampling. Here, we will divide the population into non-overlapping subsets, and we call those subsets strata. So we pick a particular variable and then we divide your population into different possible values for that variable. For example, if your population refers to people and you chose the variable age group, then we can come up with different non-overlapping subsets based on the possible age groups in the population. For example, you can divide them into kids, teens, young adults, and senior citizens. So you have your general population divided into those different categories. Now, under stratified sampling, you have to get responses from all those categories. So for every strata, there should be representatives to your sample. So if you have an idea about the proportion of these categories to the entire population, then you can use the similar proportions to your sample. For example, if you know that young adults in the entire population is 50%, then you can use the same proportion for your sample. So your sample will also contain 50% of young adults. Or if you know that uh, 5% of the entire population are senior citizens, then 5% of your target sample will also be senior citizens. So you can use the similar proportions of the population to make the sample truly representative. Now, if that information is not available, then what you can try to do is to just get an equal number of measurements or equal number of elements from each strata. But that's only the worst case scenario. As much as possible, try to get the proportion, the proportional number of elements to the population. Another probability sampling method is called multi-stage cluster sampling. So here, it's very similar to cluster sampling, but to stratified sampling. However, here we will divide the population into different stages. So first, we divide the population into multiple clusters, and then we will do that for different stages, and the stages have decreasing scopes. So we form clusters per stage, and then it's called cluster sampling instead of stratified sampling because not all clusters will be sampled, meaning that the sample will not include elements from all the clusters. So some clusters will be included and some will not be included, and that's the main difference between cluster sampling and stratified sampling. Now, cluster sampling is usually done in a multi-stage approach, wherein again, we divide the population into different clusters per stage, and then we get respondents in decreasing stages. So an example of this is conducting a national survey. So you can start with the biggest, the main population, which is the entire country, and then you can go down lower to the stage in terms of islands or major island groups, and then go further down to regions, and then after regions go to provinces, and then after provinces, cities and municipalities, and finally down to the barangays. uh, Visual representation of multi-stage cluster sampling. So again, for a national survey, we start with the main population, which is the Philippines, and then we go down lower to the first stage, which includes the three major island groups. So in most studies, we still stratify at this level, meaning we will get respondents from every major island group. So we have one from Luzon, we also have respondents from Visayas, and then also from Mindanao. Now, in the next stage, this is now considered cluster sampling because you will not get data from all the regions in those major island groups. For Luzon, we know that there are 7 regions. We have regions 1, 2, 3, 4A, 4B, 5. We have CAR, and we also have the NCR. But under cluster sampling, we won't get data from all the clusters, but we will only randomly select clusters out of all those clusters. So out of the 7 regions in Luzon, we can just randomly select 2. And for example, we got regions 1 and then region 4A. Now we will also do that for the 2 other major island groups. For Visayas, let's say we randomly selected 1 region out of all the regions in Visayas, and then you got region 6. And for Mindanao, we randomly selected 2 out of all the regions there, and we randomly select region 10 and ARMM. Now we go down one stage lower again. So now in terms of provinces, so from region 1, again, there are multiple provinces. Aside from La Union and Ilocos Sur, we also have Pangasinan and we also have Ilocos Norte. But again, here we are using cluster sampling, so we don't have to get data from all the provinces. We can just randomly select 2 out of all those provinces, and we randomly selected these 2, La Union and Ilocos Sur. and you will do a similar activity for the other selected regions in the previous stage. So we randomly selected region 4A earlier. So now at this level, we will also be randomly selecting provinces out of all the provinces in region 4A. And let's say we randomly selected Cavite and Rizal. For region 6, the provinces that we randomly selected out of all the provinces in region 6 are Aklan and Iloilo. And then for region 10 in ARMM, these are the randomly selected provinces. And again, you can go one stage lower again. So now in terms of cities and municipalities, so there are a lot of cities and municipalities under all of these provinces. But again, if we use cluster sampling, not all those cities and municipalities will be represented. We can just randomly select cities and municipalities out of all those cities and municipalities from the provinces that we selected earlier, and then from there we can choose your respondents. You can even go lower into the barangay level, and after the barangay level you can also identify further to the household level. So we call that multi-stage sampling, and multi-stage sampling is normally paired with cluster sampling. For non-probability sampling, we have the following. We have convenience, purposive or judgment, voluntary response, and snowball sampling. For convenience, this refers to the process of choosing respondents that is most easily accessible for the researcher. This refers to the researchers giving out the surveys or the instruments to the people they are familiar with. So if the researchers are students, most of the time convenience sampling happens when the researchers just give out surveys to their friends or to their classmates. Or if you just visit the establishment once and you conduct all the data gathering for one particular visit only, then again, we also consider that as convenience because that's the most easily accessible for the researchers. There is no randomness involved in the selection. The other characteristics of the population are no longer present, which makes it non-probability. Another non-probability sampling method is purposive or judgment sampling. Here, we choose a group of respondents that is based on the judgment of the researcher. So it's subjective depending on the choices or the preferences of the researcher. For example, if the study is about the studying habits of Loyola School students, purposive or judgment sampling happens if the researcher chooses what he or she thinks is an ideal Ateneo student. So if the researchers know certain kinds of people or certain people who are considered to be ideal and they choose those ideal students as the respondents, then that's considered as purposive or judgment because again, it's purely based on the judgment of the researcher. So it's non-probability still because there is no randomness involved in the selection of the respondents. Then we also have voluntary response sampling. Here, this refers to the process of choosing respondents based on self-selection of the respondents themselves. So this happens when the respondents volunteer to participate in the surveys. For example, the customer feedback forms in different restaurants. That's an example of voluntary response because no one asked these customers to participate, but they just participated on their own, which is why it's considered non-probability because it's purely based on the self-selection of the respondents. It was not selected randomly as compared to other sampling methods. The problem with voluntary response sampling is that most responses here are representing extreme opinions. So for example, in customers, most people who answer the customer feedback form only answer if they're very satisfied or if they are very disappointed. So most responses from voluntary response sampling are extreme responses. That's why the dataset obtained through this sampling method is not really representative. And then finally, we have snowball sampling. So this refers to the process of selecting respondents if it's difficult to identify members of the target population. For example, if the study is about people diagnosed with HIV, snowball sampling is the process of getting respondents based on the network of the response of the respondents. So for example, you've identified one person to be part of the sample. You will rely on the network of that person to identify succeeding respondents. So it's like networking. So you keep on adding more respondents based on the suggestions or based on the networks of the previous responses. That's why it's called snowball sampling. Or another example is for black market, for example, maybe drug lords. So if your study is about the behavior of different drug lords, then it's not really easy for us to identify which people are the drug lords, or we don't really have a database of all the drug lords in a certain area. So we start first with one element, and then we get respondents based on the suggestions of the first respondent. So we rely on the network of the respondent to identify the succeeding ones, which is again why it's only considered as non-probability sampling. So again, non-probability sampling is a valid way of getting responses. However, it limits the interpretations and the analyses that we can use, especially in terms of inferential statistics. If you used a non-probability sampling method, then it's inappropriate for you to use inferential statistics tools because your sample using non-probability sampling is not representative of the population. Now, once you've selected your sampling method, the final step in designing the research is to conduct a pretest. In a pretest, we conduct a preliminary survey for us to fix confusing questions. So based on initial responses, we can ask your respondents which of the questions need fixing because they were confusing. You can also identify variables that were missing. So maybe after conducting your pretest, you found out that you forgot to ask for age, which is a very crucial variable for your study. So that's also something that you can identify through a pretest. Also, it can help you identify if there are variables that are unnecessary. So maybe you asked for the time spent inside the establishment, and then eventually you found out that you don't really need that information for your study. So that's also possible in a pretest. And finally, you can use a pretest to estimate the completion time for the research. So when you conduct the full-blown data gathering process, you have to inform them of the estimated completion time, and that can be estimated in a pretest. So it's really important to conduct a pretest before you proceed with the actual data gathering to make sure that the data you will be gathering from the respondents are accurate and valid. So once you've created the research design and you've successfully gathered the data based on the design of your research, the next step is for you to perform data collection and data preparation. So just try to implement whatever you planned in the research design, and once the data is available, we now proceed with data preparation. Now, in data preparation, it includes the following: data cleaning and then data enrichment. So we clean the data set first, which involves removing outliers. So if certain values of the variables are very far from the other responses in the data set, then you have the option to remove them from the data set. Or if you notice that some of the responses are incomplete, for example, in one specific element, 10 questions were answered and then 5 questions were not answered. So you have also the option to remove all those responses or try to use a different technique to fill the missing information in the dataset. Also, data cleaning involves standardizing the formats. So if you ask for a particular variable that can be expressed in different terms, then you have to pick just one unit of measure that will be used for all the variables in that dataset. For example, if you asked for total time spent inside the establishment and some of your responses as respondents answered in terms of hours and some in terms of minutes, then you have to pick just one between the two, which will be used consistently for all the elements in the dataset. So either convert all those responses into hours or convert all those time spent into minutes. So data cleaning again just involves fixing the dataset, making sure that the responses are valid, minimal errors, so that once you run the analytical tools, then you can be sure that the interpretations and the findings will be accurate. Now, data preparation also includes data enrichment, which refers to addition of data derived from the clean dataset. So maybe after cleaning your dataset, you were able to come up with a dataset with 10 columns. So you were able to get 10 variables from the dataset, from the survey. And data enrichment includes adding more columns to your dataset. So this includes a computation of certain ratios. Let's say in your dataset, you were able to gather information such as the total amount spent and the number of companions to the establishment. So using those two information, you can add another column to your dataset which computes for the average amount spent per person. So that's just the ratio between the total amount spent and number of companions to the establishment. So that's one additional column for your dataset, and we call that data enrichment. Or you can also come up with additional columns based on responses from another variable. For example, if you have the total items bought by a particular customer in a certain establishment, from there you can also estimate the amount spent of the customers. So data enrichment again just utilizes the available information and try to come up with other possible descriptions of the elements based on those existing information. So after cleaning the dataset and after enriching the dataset, you can now proceed with data analysis, which refers to the use of statistical tools to address the research questions. So now we start using the different statistical tools such as the computation of the average, the creation of bar charts or the creation of pie charts, or the use of statistical tools such as simple linear regression or cluster analysis. So again, in this part, we just try to address the research questions using different analytical tools. And this also includes the interpretation of the results. So if you used a particular statistical tool, you will have to provide interpretation of the findings or the results of those statistical tools that were used. So again, in this part, the goal is to just use all the appropriate statistical tools in order to address all the research questions that were created in the first stage of the research process. And finally, once you have analyzed the data that you've collected for your research, you now have to report the results. So this includes the preparation of the report, either in terms of a written report or an oral presentation of the findings. So you have to report the findings of your research to the intended users of the information. So if the research was conducted for a client or for the management of a company, then you have to present the findings to them because they will be using those for their decision-making processes. So the style and the organization of the report must be adjusted to the target audience, occasion, and purpose of research. So if the statistical tools that you use are very technical or not easily understood by people who are not familiar with statistics, then your task is to simplify it for them. Try to explain it to them without using technical terms. Try to explain it to them in a way that allows them to appreciate the findings of the analytical tools without really going into the technical details of the tools that you used. So use the style that you think will be best suited for the audience. If your research is for the management, then maybe use terms that they are familiar with. Or if your audience are students, then use a style of presenting or use a style in the paper that makes it easier for these students to be able to grasp or understand the findings of the study. So again, the main goal here is to translate all the findings of the study into a form which is easy to understand by the target audience, because they are the ones who will be using this information for their decision making processes.